Hello, and welcome to this lesson on computing integrals using integration by parts. Today, we're going to solve the integral of e to the x times sine of x. Our goal is to compute this integral step by step. To tackle this problem, we need to use a technique known as integration by parts. Here's the formula for integration by parts. The integral of u dv is equal to u times v minus the integral of v du. Our task is to identify the two parts u and dv, and then find du and v. Next, let's choose our components u and dv. Generally, we choose u as the function that becomes simpler when differentiated. For this problem, we'll choose sin of x as u and e to the x dx as dv. Now that we've chosen our u and dv, we'll find du and v by differentiating u and integrating dv. Next, we apply the integration by parts formula. uv minus the integral of v du. Substituting in our quantities, this becomes e to the x times sin of x minus the integral of e to the x times cosine of x. Now, we haven't solved the problem yet, since we still need to compute the remaining integral of e to the x times cosine of x. To solve this, we'll apply integration by parts once again, this time choosing cosine of x as u and e to the x dx as dv, finding du by differentiating u, and v by integrating dv. We get. Now, let's apply the integration by parts formula once again. The integral of e to the x times cosine of x becomes. Notice that this brings us right back to our original integral. To solve this, we equate and solve algebraically. By transferring terms and factoring like integrals on both sides, we then find the solution. So there you have it. We found the integral of e to the x times sine of x using integration by parts, a useful integration technique.